Every day, across the world, the combustion of fossil fuels, deforestation, transport and industrial processes pour 79 million tonnes of carbon dioxide out into the atmosphere. Practically half of these emissions remain in our atmosphere. Peat bogs, meadows and forests absorb a quarter. Another quarter is absorbed by the oceans. Only when it dissolves in the oceans, CO2 changes the chemistry of the water, making it more acidic. As a result, the pH of water appears to have fallen by 0.1 units since the Industrial Revolution, the period in which human activities became high producers of CO2. It is thought there will be a further fall of between 0.2 and 0.4 units before the end of the century. This alteration in the chemistry of water is bound to have consequences for the marine ecosystem. And it could contribute to a reduction in the level of sea plankton, which is the first link in the aquatic food chain and also the main source of the Earth's oxygen. There are also tiny marine organisms that use calcium carbonate to form their shell. It's a compound that could become increasingly rare if water becomes increasingly acidic. To date, not enough in situ studies have been undertaken, and we can only make assumptions as to how the acidification of the oceans will affect marine life. The eFOCE project's team wants to go further. The idea is to inject some carbon dioxide into a particular marine zone in the Mediterranean, then to observe and analyse, using instruments and very precise readings, the consequences on the marine environment. These tests will enable us to better understand the impact of greenhouse gas emissions on the oceans and marine life. Better understand in order to better respond and safeguard the marine ecosystems of our planet.